Welcome everyone. Today is our Friday webinar and we're going to be going over ImageTank today. David is here, David Adalsteinsson, who is the founder of our company, and he is also the designer of these tools, the creator of these tools, DataTank, DataGraph, and ImageTank that we're going to talk about today. David's also a professor of mathematics at the University of North Carolina. And David, I'm going to hand it over to you.
I'll just sort of say quickly as sort of a motivation of it. I've been doing this DataTank first as part of my own research and computing. And I'm a mathematician by training, and I'm more specifically, I'm an applied mathematician focusing on scientific computing. And I do a lot of collaboration with other departments here at Chapel Hill. And these tools have sort of evolved in that collaboration to kind of bring computing and computing kind of infrastructure and methodologies to other collaborators, like in biology. Like before it was in sort of engineering and computer science, now it is more in like biological sciences, and image processing is connected to that. So what motivates all of these tools is sort of the first, kind of from a scientific point of view, I'm trying to bring a computational skill to computation to sort of the scientific community in particular. And so that kind of motivates what I'm focusing on, how I design things, and what I'm focusing on primarily in terms of kind of market as target audience. And so one thing that is sort of channels through it, and you should sort of, this is, I think, so hopefully evident also in DataGraph, is that I'm trying to work on like the scientific understanding and like exploring data and exploring your results. And what DataTank and now ImageTank do a lot also is, and DataGraph to a smaller extent, is to fold in computing into this, like coding and calculations into this, not just visualization, but visualization and a computation component. And of course, this all needs to be presented both so you can understand it and then you can relay it out to others, right? Presenting on screen, presenting in papers and so forth. So just to sort of start, it's easy to get started with ImageTank. ImageTank is, well, how they're related is DataTank started, got sort of attention through the Apple Design Award. DataGraph grew out of what I saw was the need at the time, and I think there's still a big need for more tabular data understanding, but DataTank is more kind of spatial and computation. Recently, it was clear that DataTank really needed to adapt more to the image processing, and image processing here is defined more as microscopies and pictures being captured by sort of, not so much by cameras like sort of your iPhone camera, but more by microscopes. And these are big microscopes for 2D and 3D scanning microscopes. And that is, so ImageTank is kind of a redo or rewrite or re-imaging of DataTank, focused on bringing lessons from DataGraph in and focusing on image processing, but also many of the same things that DataTank uses. So with that as the sort of the philosophy and statement, let me plow into first how to get it, how to install it, and then a few demos of how to use it that hopefully show you kind of how it interacts and how graphically fluid and interactive it is, and gives you ideas of where you could possibly fit it in. And let me just move into sharing my main screen here. So it's easy to get ImageTank, right? All you have to do is to go to the ImageTank link on our website. There is the kind of a screenshot, and you will see some of this in the demo. Below that, there's a download link. When you download that link, you will get a disk image, just like you do for DataTank. Oh, let me just move over to the other. Oh, shoot. Where are my screens? How are my screens located here? There it is. And here, you will get a disk image, and this here, just like in DataGraph, you just drag that into the applications folders to install, application folder to install it. That's all you need to do to install that. There are some other applications here that is to do with like animations and creating movie animations from output of ImageTank. In terms of registration, if ImageTank detects that there's a data graph license on the machine, you don't have to do anything. It just works. And if you don't have a data graph license, it will ask you to enter in your name and password, name and email, so that I know who you are and we can sort of communicate with you, know that you are an ImageTank user, and then we can sort of send you updates and hopefully kind of build in, because we're gonna more set up community boards and discussion boards and so forth, to sort of engage the community in the same way as data graph has engaged the community. So let me just, with that out, let me just close this and go into nope, that's the wrong application. Here, let me just bring a new document, and we'll start with the simplest demo. And so an STL is a standard file format for 3D shapes, often used in 3D, like sort of construction, like sort of what's it called? The like 3D printing, right? This is a very standard form of kind of format for 3D printing. And if you look at, for example, this is a standard here, iFold, you can draw this document into the ImageTank tank, so to speak. So this here is where the data is. When it detects that this is an STL file and realizes that this is a surface object, and you can click on the variable monitor to sort of see what this surface object is, and you can drag that around. You need to kind of make this flat here in terms of how you can zoom out. And this is just an inspector that just allows you to look at the data, right? With very little graphing on that. You can also see a bigger view of it, can drag that around, and let's close this guy here.
Can you show again, David?
Yeah.
Can you show again how you got that inspector? Where were you looking for that?
Let's just do another document, and I go through it. Sort of, here is a nice picture here, red apple. Drag that in, that creates the object. That here is an inspector for your data. You can show and hide it, because if you don't need to always see it, you can hide it here, and it's always quick to view it. Think of this as in data graph, you can select a column and hit the space bar, and you see a view of that column. This is the same type of approach. This is kind of a visual inspector, very limited but quick way of seeing it. If you want to do more of a compositing view of this, you can drag this out here. And what you have here is that these are the variable objects. Think of these as your column list, but now rather than just individual columns, it's lots of different data types, much bigger data types than a single column. You can drag this here into the view, and the way that it should be read here is that you add a 3D drawing by adding a surface, and if you drag this over the surface, it draws this. If you drag this here onto the same thing, you can either overwrite what this other object is doing, or you add yet another one. So now you have two objects in your view. If you want to then,
and I think, yes, showing how you can so easily move that around and manipulate.
You can drag this around. You can also pinch and zoom to kind of zoom in and out on that graphic. Now, if you click on that tab here, there is the underlying commands, just like data graphing, kind of like there's a command list here, starting with the setting of how the camera is, right? You can adjust the kind of how this is rotated, option drag to kind of make it smooth, how the zoom in and out, and any interactivity is just changing these things for you. And you can, for example, change the background of this to be a little bit darker and a little bit sort of color. and drag this around here. This pops up whenever you go into the top left corner, just like a sort of, you can remove it or you can add to it. You can also split this. So you now have two, you tessellate, like sort of tile this up. You can drag this into the bottom of, and now you have this in two. You can drag it here separately and drag this one here also. So let me just use this as an opportunity to drag in another object and drag that into here. So here's more of a computational medical kind of simulation type thing. So, and in here, if you open this guy here, you can say, well, the Eiffel Tower, I'm going to use flat triangles. You can draw the wireframe on it if you want also. You can sort of select see how this is the underlying here. Move this around here. You can resize these. There is a splitter in between. You can resize these graphs and so to tile them up. You can also, in the color, you can set the color as well as the transparency of your object to kind of show this through. So there's a lot of compositions possible in here, zooming in, showing kind of like the underlying wires. This is kind of, there's too many triangles. There's about 500,000 triangles in this apple here. So it's going to be a little bit busy if you show the wireframe.
And I just to emphasize one really point that I think is important is that this is all just on your laptop. Everything that we're doing here is all being done on a laptop. So we don't have any heavy duty computer machinery. I mean, it's a MacBook Pro, but
yeah, no, this is a Intel MacBook Pro, so it's fanning up a little bit, as you can sort of see that it is heating up a little bit as you're starting to push the GPU, because this is done in metal, the drawing engine that Apple has. So this is being run on the GPU.
David, I think we should go on to the next example.
On to the next one. So, the one thing that I wanted to kind of highlight is that you also have the concept of kind of collections. So if you take this entire folder and drag it in, you can see here that you have 4 files that are listed as a sequence. And if you, in the gear menu, say, I want to read an STL file of it, just like the data graph, the gear menu is kind of your way to act on many of these data sets. You can go in here, and as you scrub through your time values, you will go through the different objects that you have in that file list. So this shows hopefully kind of the 3D visual aspect of it, how you have these objects that can all be, they can be displaying kind of what their level is. This one here that's the size of this file. This is the size of these files here. The variable monitor will be different for different types, but you can show them, you can kind of close down to the detail of just like the big level.
So there's one important comment that someone asked, which is whether or not all the data is, or seeing that the data is linked by reference, that this is different fundamentally than data graph, where often in data graph we import the data. Here, the data is existing on your computer and there's a link to it, correct? Yeah.
So if you look at what the file that is created here, that's a puny little file. It's a very small file, because that really is just the scripting of it. Everything here is by reference. There's very little data. I mean, there's no data being imported into it, right? So if the data goes away on your disk, this is going to be blank. If the data changes, this will be updated.
And so these are imported. We're saying importing, but literally the file, the STL file, is being dragged and dropped, and the link to that file is what is actually being automatically generated for you. You can also create those links presumably just manually.
Yeah, I mean, this one here is just, you can type in the path name if you have it. You can click on this to select it in the file open dialog if you wanted. the fact that the dragging it is just shortcut to do that for you. The shortcut creates the object of the right type. You can go in and now in here, for example, you dragged in the folder, but you can certainly add in if you have a file, you can say like view a folder of files as a time sequence. If you open that up, you get a blank one of these. If you then go and navigate into the folder, that will kind of insert this. This is now a connection to that folder. ImageTank will read a little bit of that folder to realize that you have 4 files in that folder that match it. You can also do filtering on kind of what files you want to look at and what files you therefore want to ignore. Going into subfolders, so you can have a whole hierarchy of these folders inside folders, and it recursively goes through the entire thing to find it. And so then once you have that, it detects that there's an STL file here and allows you to read in the STL. There's other things that you could also read in case that there's other files. You can read it as a raw text file and so forth.
Okay, but I think we need to, keep going. I did just want to say these STL files are not files we created, correct? These are standard files that we downloaded. They're actually, because STL is common for 3D printing, you can find STL files, model files online. So this was just sort of a fun way to bring in some images so you could see really how the user interface works, just get some basics of that.
So let's go switch into another example. And this is a little where the coding starts being there's a little bit more coding involved in here. There's a little movie. If you go into this, there's a short test movie of like some ants in a little dish. And what you want to do is to kind of analyze this image and like sort of figure out where the ants are and how they move. So the first step is to drag this file into ImageTank. Now, a movie is a time sequence of photographs, right? So there's a photo type. You can sort of see that from the type. This creates that ants variable, connects it to a movie file. You can, if you want to see like what is the file, there is a side panel. There's okay, well, we'll deal with that later. So you can have the same variable monitor in here. In this case, you see this movie, you can sort of zoom in on that movie here. You can scrub through that in time to see that's the raw data file you have. Conveniently, they left the first frame blank. So what you can do here is you can say take a single time value, which is the movie picture from the ants image, single time at time 0, that would be this frame. That does not change. If you sort of scroll through, you can see that that's going to be stationary. Oh, what I didn't mean to do this immediately. What I meant to do was to go in and say, I'm going to convert this into an image. Now, an image is slightly different than a photo, right? In that it is a scalar field. And by this one here, you can see how I'm extracting just the gray scale out of it. If I select the RGB, I will have the 3 different channels viewable here. So splitting it into the 3 channels. But because it's basically a grayscale image, I'm going to move it into just a single channel. This channel, I'm again doing the same thing as I started, single time value. And just as you explore things, you can see like, as you move things, you can see how this movie, histogramming of this, single channel, single time value of that changes in time. I don't need more of this, so I'm going to hit the command K to kind of compress this down. And now I want to, because this is the background, I'm going to subtract the background from the image. That's done very easily with a subtract. You select here, select this, like this is the grayscale. Select the grayscale in initial, this is the background. And now you can select the background to be subtracted. Open this here, let's just move this here. That is now removing the background, right? So initially it's all 0, as you see that here, but as you start moving this, you can see that you're focusing on the ants. Now, the simplest way of doing this is to do what is called the thresholding. And you can do a thresholded path here.
Because just to set this up a little, what you're trying to do is identify the location of each ant, correct?
I want to, and I can zoom in on this. What I want to do is to figure out the location of this ant. And because it is now a sort of like the background is more or less gray, right? I have this constant color. This is a different intensity of that color. So if I take a thresholded or sort of version of this, I should be able to get that shape. Now, this is what this does. It's level set, contour, threshold, goes by many names. But the main thing is that you have a variable that you can vary here to see that threshold. And if you zoom in on the ant, and I don't know if that shows up nicely that you have this is the threshold of it. Now, because of noise, you have these little speckles here and there. So if you go into this, but you can see how it moves. As you move the video, you can see in real time kind of how that calculation is being updated as you go through that, or as you go in sort of stepping in time. So then,
David, do you want to maybe put one of these on also on the larger view?
So, okay, good. So you can now composite this. Let's say, for example, as the behind everything is going to just be the image. Like that's just the raw image from here. Then on top of that, I will draw the level set and of this. And if I draw that and make this a different color, change, you can sort of see how that color goes here. I'm going to use a fill color, then I'm going to put something in a slight opacity to that. So then this is the setting of that. And again, you can now start seeing the ants as you're moving. There's still, and the loop tool is everywhere, there's still a lot of kind of small specks in here. So we are, this is the raw data of that. Now there's an action to remove small loops. Now,
so was that from the gear menu again?
Those things are from the gear menu. The gear menu is context sensitive. So for this one, you get the actions that you can do on an image. For this one, you have the actions that you can do on a path. And this here is a processing step to say, well, if you look at this, you can zoom in on that. You can sort of see that these would be this is the detail of that. And if you set a threshold here of I want to exclude anything that is small, where the length is below a certain threshold, you can see here how that will be affected by this. And again, everything is moving in time as you scrub through to make sure that your parameters, yes, the head can go, but I want to make sure that the torso stays. And you can sort of see that you can see here the entire pipeline through. You can have all the steps in here. And as you scroll through it, you can see how that affects it. The fact that you went from 52 loops down to 20 loops in terms of where the ants are. So this button, like this here and here, this is really a more visual exploration of how the parameters work. Because a lot of image processing, you have to come up with these magical parameters. Tweak this, tweak that, things will work out. How do you see that? Rather than do them and then to like hope that the rest is okay, you can see immediately the effects of those parameters along the way. And these settings here are geared towards understanding those parameters in your data set. both for the data set you have, you can zoom in and view that, you can scroll through the time and view that. As you change your parameters, everything gets updated, including what this does after that. So this is showing you the entire pipeline, including removing the small loops as you're varying things.
David,
Now,
can you, in the interest of time, I think that the last thing you can do here is also make a table of
yeah,
all
so
of the
what I want to do
different
is,
ants.
like, I'm quantifying this. This is more here. I'm going through and looking at the center of mass of all of these guys here. So if you drag that and add that as points, let me just close this. You can see that this would be then taking those trimmed loops, taking that creates a table with the center of mass, how big is it, how long is it, if that is off the edges or not. And then as you go through, you can see that that is all updated here. Now, you can process this further, or you can combine all of the time values and drag that. Now, notice when I drag this, because this is a sort of, let me put the following, let me drag this down. It doesn't, the order doesn't matter. So, and let me open up this. This is an indication of how, what I have read from it. So as you scroll through, you can see what it reads, because it's reading from the movie as you need it. And I'm gonna go in and cache on disk. There's a way of kind of making sure that it's, and here I have a combining all of those tables for every frame in the movie. And there are 500 frames in the movie.
So a couple of questions.
And if you open it, it will start computing. You can sort of see the user UI is still responsive as it is computing it. And this is the progress bar you have, and you can sort of see how it's grinding through it. Yes, your question.
So question, asking about, can you track one ant in time? And I don't think that specific functionality is there yet, correct?
So what is here, what we, let's just move this into a layer that is below the ant. And let's take this, here's the, so combine is here, quantify is here. Let me just change this, and I'm gonna get to this here. Let me change the color so that it's a little bit, yeah. So let me just start looping this and start playing it back. So this is the kind of the whole thing of it. Right now, as I'm animating this through here, it's showing everything because I'm displaying everything. Now, in terms of the question of, can I track a single ant? The data to track a single ant is in here. Like, this is the combined thing for all of them. What is missing here, of course, is the one that you start with an ant and then go time to time to time and figure out where that ant goes. That would be the tracer, or sort of a tracker through time. That is not built in at this time. Certainly it makes sense to do, and I've built those things as codes that can call into them, sort of use it. Now, there's a way to add your own code logic to it, and that's going to be the next demo quickly, right? So like a tracker like this has a lot of things that need to be kind of parameters to figure out how far to go, how far to search. And as with everything, I kind of need a use case for that. So that is on the list of things to add as you need these. And this works in 3D just as well as 2D. So it's the same idea in 3D. And so that clearly is pretty clear that this ant is recognized in every frame. Sometimes it goes up against another ant, so you have to figure out what is logical after that. But all of the data is here. The data is not that big. It's only 3,000 rows, so it's not hard to do a brute force patching job on it.
Great. I think I know there's some other questions, but let's go ahead and, David, have you get to the next demo.
So next demo here. So I've done I wanted to talk about the scalar field. So here, if you look at the scalar field in data graph, right? So this is an addition that was in the beta for a while and came, I guess, this summer, right?
Yep, in I think June, and we demoed it again in the webinar in the beginning of September.
So this here is a column of data that then gets reshaped and mapped into this object here. Now, what I did here was that I went out and did export data, selected a data table document as the export format. And I got this file saying like single column .dtable is what came out of that. Now I'm gonna,
I guess quickly, anyone who's not familiar with the dtable format, that is a general format that allows you to go between DataTank and data graph, correct? And now ImageTank as well.
So dtable is, yeah, it was created sort of, it came initially to data graph when I created the R package, right? So you can go through CRAN and get a data graph package for R to allow you to save a dtable file from R. A dtable file is just a data frame or a single table in a file. And when you have that file, you can drag that file back into the ImageTank. And what it will detect is that this is a data file that currently contains only one value, that is a table, right? The R package allows you to do multiple tables into one file and sequences of tables, and that's what this will understand more generally. I take this file here, select it, create the object from that, and that's what this is. And here are the numbers, right? So this here is the list of numbers that came from here. So this is one way of getting the data. And as was pointed out before, this is not, you don't copy it here and paste it into that, because ImageTank is meant for things that scale a lot bigger and where you can have multiple views on the same data. So it's really views the data as separate from your computation. But this here is just a list of numbers. If you look at what this does, it takes that list of numbers and says it's a uniform row first 87 by 61 with a step size of 1. That stripes it out into your scalar field. Now, I need to do the same thing here. I don't have an action built in to do that, say yet, but it's easy to add. And the way that it was added is, since what I want to do is a scalar field, which is called an image in my setup, right? You open up a task and you say, I want to create an external program that returns an image back. So I did that in here, and just to sort of, and that is, if you look at the setup here, this is how you define an interface between your ImageTank file and a C++, in this case, code behind the scenes.
David, why don't you minimize data graph just so we can simplify your screen a bit, if you don't mind.
Yeah, so here, and this one here takes the input. You can vary the input, you can specify the input. It auto-generates the code needed to do that communication. So what you're left with is to implement the code that takes in a table, dx, dy, m, and outputs an image. And it helps you a little bit with like how to get the data in and out. And let me just open up the code that I wrote. This here was suggested. I only take the value and the m that comes in from here and reshape it. If you're used MATLAB, it's a very common operation to kind of look at a list as an array. Then that gives me a block of numbers, and then I create an image with one channel called height with that data block, returns it with a dx and dy coming from here, and that's all I wrote. So really I wrote this, and a lot of the code behind it is already auto-generated. This, of course, depends on a fairly large library of C++ library that comes with it. And if you look at kind of where it is, it's embedded inside the ImageTank application. This is not an extra download. It is part of the ImageTank application. So this here shuffles it back and gives you this result. Now, to get this, what ImageTank did was to take this, send it to an external program that it ran for you, came back and displayed it over here. And what you can now do, is you can draw this data here. I have already 2 split windows. So I'm going to draw this here. And in that view, say, well, this is the height is going from the height. The coloring is grayscale. I can make that a single color, or I can make that a rainbow color. I can vary the coloring range of that in terms of how you want to color it. And you can also add in the underlying grid here on that. You can draw this also in 2D, just the same way. Open this up, go open this up, change it so that it matches the other rainbow color. And that this is how you can draw a scalar field in 3D, in some sense, zoom in and out on that, as well as 2D. Now what you want to do is to say, okay, so then this is just the visualization. There's nothing, no computation here. One thing you want to do is to find the peaks of this. So that is an extrema. So what you have is you can do a local extrema. Again, you can pick up that the local extrema has to be at least 3 points away from each other, and the value has to be at least 0. So that is the points that you have here. So this one here gives you those. As you vary the parameters, you can see that fewer extremas survive because they're too close. So this one here,
David, what is the difference between the red points there and the green
so
points?
the way that this kind of does it, and this should be explained in the help document, which is accessible here, right? That if you move it, let's say move it down to this, like the green points are all of the extrema. Like extrema is defined as a value that is larger than all of its neighboring values. And neighboring values is 1 pixel, right? Now, these are all the values of that form. Now, if you increase this search radius a little bit, clearly these were so close that this red one was less than 2.12 pixels away from this other local maxima. And that local maxima was larger. So this is therefore not considered a local extrema because there's a bigger value than it within a radius. This is very similar. This is the 2D version of what data graph does for a local extrema for a list of numbers or XY values. But that's just now it's more of a spatial thing. As you go through.
That's good. Why don't you show us the points?
So now if you want to draw the points, you can draw them in here and they show up here. As you go through, let me move this to the left a little bit, hold down on Option key I want to fit this on the screen. There it is. So now I can see both. And as I vary this, you can see how the points are fewer as a result. If I drag this into that, I add in, and I need to show this here, is that I use this is XY with a height. So the table, the way that this comes from is this local extrema table. One big thing difference between this and ImageTank data graph is that the granule is not a single column, it's the entire table. And then inside of that table, you can select which columns you want to do. So the XY location comes from height, the value comes from the X point goes from the point column, which is a XY point. The value comes from a numerical column. And here are the settings. You can say, look, there's a sphere with a certain radius here and a certain color here, right? So that would be, and as you vary the size, you can sort of see them fewer. So now you got these 3 spikes in here, right? This is not a local extrema because it is an uphill to this, right?
Okay, I think we should go on to the next.
Here's one thing that I wanted to kind of just for the fun of it is we got data from datagraph. Let me send data back to datagraph. So in the local extrema, you can map the columns. This is like the expression column mechanism in datagraph, except on a table by table method. So I'm going to add in another column and option drag this to make 3 columns. Here we go. I'm going to call them X, Y, and Z, right? And the X is point.x because you can see these are the variables defined here, just like an expression. Point.y, and here is the height. So what I've done really is that I've broken this up into numerical columns. I now go and say export this for datagraph. And I'm going to say let's say my test file. And what has happened here, if I go into the Finder, is that I have my test file here. If I test file 2, you can see now there's a test file 2. It automatically saves it. If I go back into Datagraph and I take this test file 2 and drag that in here, I have my table. Oh, no, I need to, that of course is not a test. I need to make the type because the Datagraph is not going to recognize it without calling it test file 2.dt bin. That's the file, no, dt table. There is, these guys are not needed, so I'm going to delete those. That is what I want to do. This here will then be that column. And I can take these X and Y, and draw the points here. Right? So now I've taken the data from ImageTank and moved it into Datagraph using that file. But this is live. So as I change the settings in ImageTank, you can see the change inside the method inside ImageTank, but you can also see this here. You can see it in this table here. As I vary this, I'm changing everything. So this is ImageTank driving Datagraph through a pipe. So, okay, so that's kind of the extra thing that I wanted to show.
We got people like that on the chat, by the way.
Yeah.
Okay, I think we just have time for one
thing. So
demo, and then we have a bunch of questions to answer.
Bunch of questions. I wanted to show if like this one here is just kind of for the heck of it, right? So this is.
Or maybe we can just play this one quickly and then show
this.
yeah.
So what is interesting about this is that this is a simulation that ran outside of DataTank, right? The simulation was set up inside ImageTank. So not DataTank, ImageTank, right? Was set up here. If you look at the code behind it, this is the code. The code here, the wave, here's the computation. It's a relatively simple code. It uses FFTW to do a Fourier spectral method to solve the wave equation. That's basically what it is.
Some people might say this is not simple, but
okay, so that's and what you have is I ran it from here. It spat out about 1.3 gigs of data. That is this data here. You can see it as you're going through. This is the data. You can inspect it along the way as it is playing through. Now, and that is then displayed using the same mechanism as like with the height field on it. You
I think this is beautiful.
You can move it.
Can you pause on the initial condition just for a moment?
So let's move back to the initial condition. That initial condition is because of that guy here. If I change this into 200, so that's a little bit lower, and I'm going to change a little bit where it's centered, hit run, this is where it is, right? Now it's running. You can see here, this is the progress bar going on it. but you can still view what you have. You can see how it's running in the background, and the animation is going along. You can see how it is getting more and more data as it's running into it. I don't know which will finish first, the animation or the calculation finishes before the animation, but that is what you can do. You can sort of run things interactively, either immediately like before, or kind of through a bigger act of it. The throughput is pretty decent at reading that 1.3 data file. You can see here from the cache how it's reading it. It does not want to read the entire thing into memory. And that's big difference between Datagraph and ImageTank. Datagraph is memory-based. Everything you see has been loaded into memory and displayed. ImageTank is a hybrid memory disk, like just-in-time computing or just-in-time reading. So that's why the file can be a lot bigger than the internal memory of the machine, because it only reads the things that it needs. And it caches so that it's going to be, you can move that around at any point and resume the animation. And you can see these things kind of as you go. You can even go through and then have a test things like how that works. There's a lot of things you can do as everything is running, right? This is a little kind of an inspector to kind of like, I want to look at a slice through that, how that will work. I want to see how that slice is at different locations in space, and everything is updated as you do things.
Okay, let's answer some questions.
Okay.
Question. So and a couple of people had this. What about running Python programs?
There is if you go into the task, there's an embed Python program. And that embed Python program, where does it go? Here is where it went. To the side, you can take in your input variable. So you can pull in an image into it as an input to your Python program. You can add a number as an input to your like scale C. You can have your code. This is your Python code that you need to implement. It takes in a U and the C value that you have. It also has, and if you test it, it says you ran that. I mean, there's a way to test that code. Nothing is being returned really, but you can see that here print. I forget exactly what the syntax is, but the U, there is like a lot of these variable types also have a Python implementation in terms of how the data is stored, so that image, you can query it by the Python code, right? And that embeds the Python code. You can run in a debugging mode the Python code here, but if it's then working, it can pull back in, and you can decide with the output that you have is a group that's a dictionary, like a JSON object type of a thing that you return back, or you can return any of the other types that are well defined in the Python code back from your script here, right? I'm just more fluent in C++ than Python, so I did the reshape in C++ and not Python. So you could.
So and maybe we'll have a different demo to go through, or have some. I don't know if there's any help documentation on Python right now, but we can certainly add that.
Okay.
Let me get through a couple of other questions. So there's a question about adding X and Y axes with the scalar field image, and
Yes.
or say the volcano. Can you add something that would show you what the X and Y axis are on the images?
So the way
I don't think we quite have that yet. Is that correct?
We don't have that yet. So in here, the way to like where that should be and where that will be, right, is if you look at the site, there's a toolbar here with the commands that you can add. Some of them you can drag in, others you can just add in. So if you here, for example, you can add in a plane at a certain height, right? And you can sort of, well, it sort of is obscured, but you can sort of see it underneath here. There should be an axis setting here, right? The same way that there should be an axis setting here. I mean, for this one, typically you add a scale bar. So you can add a scale bar in the lower left, which you have as, did I move that out? So, and
that's fine. I mean, I think it's fine that there's not a traditional X and Y
here it is
in the way that you
have
in data graph. But yeah, you can add a scale bar on the image to indicate.
So here's a scale bar in terms of the unit that you have defined your image, say 0.2, and that is a sort of, this would be the scale bar for that. That's not a tick mark in the standard XY thing, but it is a size scale setting that you specify as part of the image command.
So very quickly, that wave simulation, you could have run that with Python, correct?
Well,
or no?
So the way that this wave simulation works is that there is a task. So if you go into the task, there is a run a task. You can pick from existing things that you've already created in the past, or you can create a new one. That is the one that sets up. Now that's at the moment completely focused on C++. Next option would be Swift, if any, like that would be a natural next candidate. The Python could be one, but then because it needs to, there's some like it would need to write that file format to be pushed out. There's nothing impossible about that. You would sort of set up, because at some level, this is a command line utility that you're running. And that command line, as long as you can run it in the terminal, you can run it here. That's all that ImageTank is doing, is to take the executable. It just knows where the executable is based on the fact that this is an Xcode executable.
So do I understand correctly, the Python, the way you embed Python with that, creating the Python task, it's more like a plugin? Yeah,
so what I did to flatten the data is let's call it a filter or a plugin or something that gets added as an action, just like this is an action. This is a slightly different way of running an external code, which is you launch it when you want it. That's when you click the run button, and it monitors the output out. Both are command line utilities behind the scenes, and both could be used. You can wrap a command line utility to be called on for you. And that, there's nothing stopping you really from writing that command line utility in whatever language you want to run. That could really be just a script that launches Python and does whatever you want to do, right?
Now let's go to a different question. Yep. For when we were doing the ant simulation,
yep,
and we were doing the thresholding, someone was asking about, would it be possible to smooth out the contours on those thresholds, for example, so that the ants would have a smoother look to them? And I believe all those types of functionality are there, correct?
Yeah, let me see.
Smoothing and...
There's the ant.
Yeah.
Happen to have it. So in that grayscale, you can then smooth that. And if you open that up and you zoom in on something and you drag in, there's a red bar here that's sort of hard to tell. That is the effect of that smoothing. So the smoothing, you can vary the smoothing aspect of it, so you can move that into just a little bit of a smoothing. So this is the smooth.
Although that's smoothing the image, I think the question was more when we found the thresholds, or maybe it accomplishes the same thing.
So the thing is, when the reason why these guys here showed up as speckles is because they really are noise, right? And then these are rough because of the noise effect of it. You can sort of see that here is a little possibly a speckle, but that is going away when you smooth it based on the Now, you can pick which smoothing you want, Gaussian or box or median smoothing filters, right? But then if you want to run that on all you need to do is to switch what you're using. Are you using the grayscale or the smooth grayscale? And everything else gets updated with it. In fact, it's already done, right? So
it's hard to see the impact because we did it so quickly.
So it's sort of everything is live. So as you change this, you can see how look at kind of the tracks here. As you're going through this, you can see how the tracks are affected by that smoothing action. Not much, but a little bit, right? And by changing this, the whole pipeline is redone, including combining all the time values. And if you had an action that would then tie together your points according to some heuristics, that would be automatically run for you also. Now, last thing, and I'm not going to explain it, I'm just going to sort of intimidate by it, right? Is things can get very complicated, right? And here is a big script. And it's already, this is already running, right? And I don't know if I can.
So what David is also showing, this is from a paper that was published a couple of years ago using ImageTank to do processing of these TIFF stack images from a microscope.
I don't know if you noticed that the CPU was pegged at the time. Let me just close this and open it up again. Because when I open it, it launches into the calculation. You can sort of see the CPU sort of being hammered by that because the ImageTank is heavily threaded. So it spawns uses all the cores that are on the machine to do the calculations. And you can see this is the end result of now a whole bunch of steps, right? There is a lot of steps that go into various kind of registration to align the picture, doing background subtraction. All of those things are just individual objects, then go on and on and on. There's lots of figures that have been created for it. And you can pick which one you display on that. There's some measurement things on it and so forth. You can, like this one is here, you can also tile this and show this in the previous one. There's a lot of things you can do interacting with the data set. And that data set is starting to be up there. So it's about 3.6 gigs, 25 time values of a 3D data set that you can slice through in space along y-axis or along the z-axis. You can also scrub through in time.
All right, David, I'm going to cut you off. The quick question, DICOM medical images.
DICOM. So I happen to have code lying around to read some of those, and that was used in DataTank, and I have yet to incorporate it into ImageTank, but that would make sense to do.
Okay, great. I think we've gotten our 60 minutes. I'm trying to not have these go too long. Thank you so much, everyone, for attending. We will be having the forum live for ImageTank. We didn't really quite have it going before, but we're going to have it going again so that people can ask questions on the forum. We'll be sending out a message and posting some of the files that we used today. I'm trying to think if there's anything else quickly that we want to mention. David, can you think of anything?
No, the main thing is that just like Datagraph evolved quite a bit and was helped by kind of feedback and sort of interest by the community, ImageTank, I want to do the same thing. Clearly, ImageTank is currently kind of a historical path of what I've been doing for the last few years, like collaboration-wise. But I'm definitely, this is a foundational tool. This is a foundation for a lot of calculations. And I have code lying around from the past, from DataTank, because DataTank was my path for the previous 20 years, right? So this is now going forward. And I have code that I can repurpose and do things here. There's also a lot of times, really, you don't need a lot to be added into the program so that it enables you to get the data in and start working with it. There are ways to write your own import plugins and the calculation plugins. And now what you cannot do yourself is the graphical drawings of it, but that's definitely show me a use case, interact with me. It's fun to explore that. And if it's too complicated, I'll say that I will think about it, right? But many things will be easy for me to add, maybe easier than you expect to add to it.
Great. That's fantastic. Okay. I think on that note, there is a knowledge base for ImageTank. So although the form isn't up right now, it will be up again soon. And there is documentation there. We'll be continuing to add more documentation. And we will be posting this video also on YouTube. So I hope everyone has a lovely weekend. You're welcome. Thanks so much for the positive feedback on the chat. I know, David, you're not looking at that right now, but
Yep.
People have definitely appreciated the presentation today. And yeah, but very interested to get, if you have other feedback you'd like to give, then also emailing us, help@visualdatatools.com is another great way to communicate with us. And with that, I think we'll be ready to go ahead and end the webinar.
Yep.
Okay, great.
Right.